How's everybody doing today? This is Mr. Roderick, and we're going to talk about 6.5, which is theorems about roots of polynomial equations. Basically, we can solve cubics if they're nice, in other words, sum and difference of cubes. But right now, we're going to learn how to handle all these other situations. For example, like what we have in our picture here. I'll give you the equation of that in just a second. But basically, that has you can see one real there at -1 and two imaginary crossing points. And if it's not factorable nicely, well, what do I do? And that's basically today's lesson, okay? So the equation to that guy that we're looking at right there, that is the graph of 3x to the third plus x squared minus x plus 1. Okay, so I look at that thing, it's definitely not a sum and difference of cubes. So I'm like, well, what the heck do I do? So we've stated lots of times that if I have a cubic, it's always going to have to cross the x-axis at least once. So we're going to find that point. Okay. Today we're going to find it just in our graphing calculator. Okay. We know how to do that. I'll tell you that x is -1. Okay. And basically, um, the way that you can figure that out for sure is the factors of the last, which is this +1, the last term, so plus or minus 1 are the factors there, over the factors of the first, plus or minus 3, plus or minus 1. So in there somewhere, you're going to have the root that your picture crosses at, okay? And in this case, I'm going to just tell you from the technology that we have, we're going to say that -1 is our crossing point. We see it, we can confirm it, we're all set. And all you do is you put -1 in the box, that's the root. So we do synthetic division, just like just like old times, and I put a 3 here. X squared is a 1, minus 1, and 1. And we do our synthetic division, and we go ahead and we get 3, -3, -2, 1, excuse me, 2, 1, and then -1, and then yay, remainder is 0, right? Which is what we're expecting, because when I put that root in the box, when I divide, I better get 0 as my remainder. So now I'm left with this quadratic of 3x squared minus 2x plus 1, right? And how do we solve that? Well, it's not really factorable. Try to run a board on that. Nothing good happens. And we're left with going ahead and doing our quadratic formula. Okay, so we got x equals 2 plus or minus the square root of 4 minus 4, 3 over 2 times a, which is 6. Okay. For purposes of this lecture, I'm going to let you go ahead and do that on your own. We've been working on that enough that you should be able to come up with the other two solutions. X equals 1 plus or minus I square root of 2 all over 3. And again, if you break this out into 1 over 3 plus or minus I square root of 2 over 3, and I would say you're good. All right, so that's our basic lesson for today. From the top, basically what we did was either by using technology or using our rational root theorem, we basically took the factors of 1 here and the factors of 3 here and listed those and said, okay, those are our possibilities. And then we went ahead and looked at our graphing calculator and found the one real root. And we said, well, we know we're going to have two imaginary roots based on our picture. And then we found those using the quadratic formula once we went ahead and did our synthetic division. Okay? So that's a lot of process today, in that one thing. But basically, you practice this a few times, and now you have cubics that are not sum and difference of squares. You can still solve and find the solutions. Okay? All right. Um, there we go. Go on from there. And um, we'll let you do that as a quick check tomorrow in class. All right. Now, there's a couple of things that the last skill that we need is basically given some information or given roots that we have, can I get more roots? In other words, if I have square root of 5 here, which is irrational number. So 2 minus the square root of 5 is one of my roots. Okay. Basically, because I have a irrational root, I basically can say, well, if 2 minus the square root of 5 is a root, then its conjugate, right, its partner of 2 plus square root of 5 is a root. Okay? And by the same token, square root of 7, well, that's an irrational number, right? Does it repeat? Does it terminate? And if that guy's a root, then we can also say its conjugate, which is just negative square root of 7, is also a root. And basically, guys, this is because we keep talking about this, and I keep drawing these pictures because, hey, these irrational roots, these imaginaries, basically, they come in pairs, okay? They come in pairs. So we're going to work this same kind of magic for irrationals as we do for imaginaries, okay? And we're going to use it predominantly, irrationals, that's nice, but we're going to use it predominantly for our imaginaries. For example, if I've got 2 plus 9i and 7i, I can say, well, if I have 2 plus 9i as a root, I know, Mr. Roderick, that 2 minus 9i is also a root. Okay? And I don't really care if you know the word imaginary root theorem. That doesn't make any difference to me. What I want you to know is if you have 2 plus 9i as a root, that you know that 2 minus 9i has to also be a root. By the same token, I don't care if you know, once you know you have a 7i as a root, you better know that negative 7i is also a root, okay? Notice when, so notice all we're doing with the 7i is changing the sign, and with the 2 plus 9i, 2 minus 9i, all we're doing is changing the sign in front of the I term, okay? So that's pretty simple, but the reason this is important, I mean, this is just fact, this is reading, this is vocabulary, but what this allows you to do is a problem like this, okay? Find a third degree polynomial equation with rational coefficients that has roots of negative 2 and 2 minus I, okay? Third degree. At this point, you should know that third degree means x to the third, okay? And then from there, negative 2 is a root. Well, that's a real crossing point. 2 minus I, that's imaginary. So if 2 minus I is a root, then we can also say 2 plus I is a root. And that's your job, is to supply this third root right here. Okay, so now I have something of third degree, and I can say, well, if minus 2 is a root, then x plus 2 must be a factor. And if 2 minus I is a root, then x minus quantity 2 minus I must also be a factor. And if 2 plus I is a root, then x minus the quantity 2 plus I must also be a factor. Now, this one is admittedly a little bit messy, and I got x plus 2 here. I'm going to go ahead and clean this up as x distribute here minus 2 plus I, and x minus 2 minus I. Ugh. Gross, a little bit. In other words, what we have to do next is take these two terms, probably, well, you take your pick, but probably best bet is to take these two terms here, multiply out and get those 9 pieces, combine your like terms, and then multiply by your quantity x plus 2. Okay, I'll let you try that. If you get all that done, again, that's just multiplication and simplification. You get all the way to the end. You get our second example there, which your result should be x to the third minus 2x squared minus 3x plus 10. Okay, this is what you get. All right, so basically, once you get to that answer, um, that'll be the end of your lesson, because basically we can take from here, we could grab our other example here, that's what it is. And from this example, we'll go ahead and just finish this off. It looks like we have some time here. Let's see here. How much time? Oh, we're good here. Okay, good. So what I'm going to do here is quickly go ahead and just to close this out, do what we did at the very beginning. Given this guy right here, find our 3 roots. Okay, so I'll tell you just to save some time here, using technology, if you put this in your graphing calculator, you will see and you will confirm that there's a crossing point at -2. Put that in the box. And then drop, do synthetic division. And oh, happy day. I have a 0 remainder there. That means -2 is a root and x plus 2 is a factor. Okay, and then I can go ahead and take x squared minus 4x plus 5 and go ahead and work the quadratic formula on that guy. And I should get, at the very end of that, what we just have already talked about. You get grand total of x equals 2 plus or minus I, which is 2 plus I and 2 minus I. So, okay, we've got a cubic. I've got 1, 2 solutions here, 3 solutions there. Those are your 3 roots. Okay? And that's basically, if you can do that one problem there, you have today pretty well covered, okay? With that and this vocabulary right here, as far as knowing, as far as knowing that if I have 2 plus 9i as a root, that 2 minus 9i must also be a root, then you can accomplish your goal there of what can you do? You can solve equations using rational root theorem and use the rational root theorem and imaginary root theorem to get through that process. Okay? Hope you're having a great day, and we will talk to you soon. Thank you.